Hello and welcome to this course on Entity Framework. My name is Hannes, I'm a Microsoft MVP in Developer Technologies, and I've been using Entity Framework ever since the first version was released around 2008. I've been using it in production software ever since, and whenever I get a chance, I love to teach it to people who are not familiar with the technology. And that is why I wanted to make this course. I want to help you get familiar with Entity Framework so that you too can use it in your software as a database access component. So let's get started, shall we? So, what can you expect to learn during this course? Now, because this is an online course and we don't really know each other, I'm going to assume that you've never used Entity Framework or any ORM for that matter. That's why I'm going to start by explaining the very basics, but if that makes you think that this is going to be a beginner course, you might be mistaken, because by the end of the entire course, we will have touched on a bunch of advanced scenarios as well. We will see how to use Entity Framework in proper unit and integration testing scenarios, how to integrate it in a bigger architecture, how to use it with a document database, and even how to apply it in multi-tenant scenarios. Now, if all of that sounds daunting, it doesn't have to be, because I've cut this course into many different modules. And even after watching a few modules, you will have enough knowledge to go and apply Entity Framework into your first projects. If you've then played with it for a while, you can come back to this course to learn more whenever you're ready. So whether you want to take it one step at a time or digest this course as a whole, I think this will allow for all of you to take this course in at your own pace. So, who is this course for and what do you need to get started? As I already mentioned, I don't expect you to have any knowledge about Entity Framework to start this course. But if you already know a little bit, that's fine too. You can just skip the first few chapters and dive into the advanced stuff immediately if you want. However, I do expect you to be familiar with the C# programming language and the .NET ecosystem. I will be using JetBrains Rider as my IDE, but you don't have to. All of the code samples will work just as well in Visual Studio Code or a full-blown Visual Studio. On the database side, I expect you to have a little bit of experience accessing and manipulating data in a relational database. Anything with a SQL dialect will do. Whether you have experience with Postgres or MariaDB or SQL Server doesn't really matter. If you have a little bit of experience, you're gonna be fine. Now for those database engines, I will be using SQL Server for most of this course, but anything I will be using, I will be running in Docker containers. I don't expect you to have a lot of Docker knowledge. I'll show you the commands that you need to get your databases up and running. Now by doing this, I will allow you to do this entire course on the Linux or macOS operating system as well as on Windows. I hope for that way that everybody who wants to take this course can actually run it the way that it was intended. Now, what is an ORM or an object relational mapper? That has everything to do with the data inside the applications that we build. And when I talk about data, I mainly talk about two things. First, we define a model, and that is a shape for the data that we will be using. We will define what our data looks like. And then I'm talking about the actual data, the individual data points. Now, those data points will take the shape that we defined in the model. Now, in a typical application, we're actually looking at this data from two sides. We're looking at it from the place where we persist the data, in our case, a relational database. In most of the samples that I'll be doing, I'll be using SQL Server. And we're looking at the same data from the code side, in our case, C#, an object-oriented programming language. Now, when we define models on the SQL side, we will be creating tables, because a table will have columns for all the properties that we want each and every one of the individual data points to have. And every data point we will model as a row. Now those rows, if we want to do things with those rows, we are going to be calling SQL statements. Selects to query the data, inserts to create new data, updates to manipulate existing data, and deletes for the data that we no longer need. Now, when we're querying and doing all those statements, we're manipulating the data points inside the database. And that's where we need that to happen because we want to store the records there. Now, if we look at the same data on the code side, if we are looking at data on the C# side, we're going to be creating classes or structs. And those will be defining the shapes of our data on the code sides. And we will create properties or fields for all the properties that we want on each and every data point. And the data point in our case there is going to be an object. Now that object will actually have all the properties that we defined in the class or the struct. Now this is all very cool. If we want to perform operations on the objects, we are going to be calling functions, because those functions will actually manipulate the data on the code side. But if we want to actually persist the data inside the database, those functions are going to have to call the SQL statements on the right side in our database. Now that's not all very complex or very innovative, but what really happens when we use an ORM, and this is where the ORM comes into play, the ORM creates a mapping between the code side and between the database side. It will take the two models and create a mapping between the two. And that mapping will actually be responsible for the ORM's functioning, because as soon as we have those two models mapped to each other, the ORM will actually provide us with those functions. And if we have those functions, we can actually call them in our code as if we are manipulating the data. And the cool thing is that the ORM will actually generate all these statements behind the scenes, so that we don't have to write them manually. And that is in essence what an ORM will do for our code. Now, why would you want to use an ORM? Well, it has everything to do with this part. If you would be developing your application without an ORM, those will most likely end up as string literals inside your codebase. You will have all those SQL statements as string literals. And that is a huge risk during the lifetime of your application. Now, why is that? Whenever you change something in the model in your database, you're going to have to change all of those string literals. Now, if you miss one you mess one up, the price you're going to pay is runtime exceptions, because the compiler doesn't check the contents of those literals against the model in your database. Now, when you're using an ORM, you're only going to provide the mapping between your code model and your database model a single time. And you can even check that mapping between those with an integration test. And that's pretty cool, because from then on, everything in your code that you're using is these functions. And those functions are strongly typed. So if you're misusing one or you're using data in the wrong shape, you will actually get compiler exceptions and not runtime exceptions, which makes the whole development process a whole lot easier. Now, the price that we used to pay for this used to be substantial, because ORMs used to be a couple of orders of magnitude slower than raw SQL statements. Now, ORMs over the years have gotten so good that that is no longer true. In the old days, I would advise you to only use an ORM for CRUD applications and for anything that needed a bit of performance to steer away from it. But today, that is no longer true. ORMs are so fast and so close to the handwritten SQL that my advice today would be use an ORM as long as you can and only move away from it for the most extreme scenarios. And those scenarios might be a hot pad in your code that gets called so often or that needs so much performance that you can no longer deal with an ORM, or the places where it gets so complex that an ORM only gets in the way. But from experience, I can tell you that in a typical application, that is only a very, very small portion of the code that you would need to move away from something like EF Core. And that's why you would want to use an ORM. So what is Entity Framework Core, or EF Core for short? For that, I'm going to take you on a trip down memory lane, and we're going to go all the way back to the early days of the .NET framework, the Windows-only .NET framework that Microsoft started the .NET ecosystem with. Now, in the early days of the .NET framework, Microsoft did not have their own ORM. So a lot of third-party vendors started supplying ORMs for the .NET ecosystem. And as these things go with Microsoft, if something is happening in their space, they want into the game. So they started developing their first ORM around .NET 3.5, and they released it with .NET 3.5 Service Pack 1. And that ORM was called Entity Framework. Now, Entity Framework, or EF, was the first ORM to come out of Microsoft, and as you can imagine, in the beginning it didn't have a lot of features, it wasn't really fast either, and sometimes it was a little bit buggy. But it had one killer feature that made a lot of devs want to use Entity Framework, and that feature was LINQ, Language Integrated Query. LINQ was something that Microsoft had recently released that allowed us to query all of the things inside the .NET ecosystem. You could use it to query things in memory, but also things like databases and APIs. Now, the cool thing about LINQ is that it allows us to make strongly typed queries inside our code that are much easier to refactor when the data models change, as opposed to string literals when we are writing queries towards our database. Now, what happened with Entity Framework was the second version was actually Entity Framework 4, because around 2010 Microsoft had a fetish on consolidating all of their numbers on version 4. And later we got two more major versions of Entity Framework, 5 and 6. And today, on the current day, 6.4 point something is still a supported version of Entity Framework. Now, when Microsoft started re-engineering the entire .NET ecosystem with .NET Core 1 in 2016, and then later .NET Core 2 and 3, and then 5, 6, 7, where they dropped the Core moniker, Microsoft figured out that they needed an ORM to match the things that they are trying to achieve in that re-engineering, which led them to port a part of the features of Entity Framework 6 into Entity Framework Core 1. So EF Core was born there. And Entity Framework Core 1 had a very ambitious goal. It strived to be much faster, it strived to have cleaner queries on the database side, and it also strived to support the web scenarios a lot better. A little bit more on that later. After that, Microsoft started porting more and more features from Entity Framework 6 into Entity Framework Core, and they kept the version numbers in sync with the release versions of .NET. Now today, Entity Framework Core is to a point where it has gotten all of the important features from Entity Framework 6, and it is the only source of development for Microsoft because they are considering Entity Framework 6 as feature complete, and all of their development is happening on EF Core. So today, if you start a new project, you would have to consider EF Core as your prime target. Now, what is the biggest difference between the original Entity Framework and Entity Framework Core? That lies in the spirit of the times. Entity Framework was developed in a time when a lot of .NET developers were building desktop applications using WinForms or WPF. And the use cases for Entity Framework actually reflected that. It was an ORM that had long-lived database connections, that supported features like lazy loading by default, and it was really tailored towards that scenario. But the world around them changed, and a lot of .NET developers started writing web applications instead of desktop applications, so you could configure the later versions of Entity Framework to actually behave a lot better in web scenarios. But the defaults always remained the same on .NET 4, 5, 6, and so on. In EF Core, Microsoft actually changed the defaults to tailor the web scenario. So the default settings on EF Core are those that are tailored towards a web usage scenario, where you want to respond to an HTTP request and return a response and then dispose of everything that you have in memory. So EF Core does just that. You can also configure EF Core to behave in a desktop scenario, but the default is definitely web. Now, with all of the features ported, today I would suggest using EF Core as your default for anything, and that's why this entire course, when I talk about Entity Framework, I'm actually talking about EF Core, because we won't be teaching any old Entity Framework, we will only cover EF Core throughout the rest of this course.